So is anybody lost? Okay, we're on page 5-22. We're going to start our first sketch on the front plane. Okay, going to start with a circle, center point coincident with the origin. And the dimension is going to be 4.9. Anybody lost, needing help? Anybody needing help at this point? Ron's sitting back there waiting for somebody to need his assistance.
Don't worry, it's all good.
Yeah. Okay. So now we're going to do an extruded boss base. So we're moving over to features. We're doing an extruded boss base, but we're going to give it a draft. So it looks kind of like a drum. And I'm on the middle of page 5-22. Okay, so I'm going to extrude it 1.725. I'm going to add a draft. My draft is going to be 5 degrees. Oops. And I'm going to put a check right there where it says draft outward. Green check. Anybody lost? Needing help? Oh, I needed to reverse the direction. Sorry, I need to reverse the direction. I need to have it go toward the rear instead of the front. So I'm going to come over and edit the feature. Sorry. And change the direction right here. Okay, so that the small end is at the front and the bigger end is toward the rear. And do you remember when we created the battery and we created kind of a well for the terminals? We're going to do the same thing here. We're going to select this front face for a new sketch. We're going to do a circle. And we're going to add a dimension of 3.875. Now some of you might be concerned because it says 3.88 instead of 3.875. That's because I only have 2 decimal places and it's going to round up. All right? Anybody need help with the second sketch? Okay, moving over to features. We're going to do an extruded cut. We're going to make it 0.275. We're going to give it a draft of 5 degrees, but this time we're not going to draft outwards. Question?
The draft outward, that's just the opposite direction of
Right,
the paper.
right. And you're going to see that in a second. I'm gonna green check it, and then I'm going to give you a wireframe so you can see. So I'm switching to wireframe so you can take a look at it and see how it's drafting one direction and then the opposite direction for the cut. So this is a draft out, this is the draft in. See that? Any questions? Okay, I'm going to save it. So now we're going to add a shell, and we're going to remove this face. And remember, our shell is right here. So I'm going to click on shell. Our shell is going to be 0.150. And then we're going to remove this face here, where the well is, and we're also going to remove this back face. So you should have two faces here. One's the back face and one is the small circle, or the smaller circle where the well is, and then green check. And I'm going to show you again what it looks like with the wireframe. So you can see our O-ring is going to sit right in here. That O-ring we made. It does. I'm wondering about that. Let me look at my cut. I agree, it looks off. Let's see. Aha! Looks like I'm missing a coincident constraint. Good thing I looked at it in wireframe so I could catch that error. Now it looks correct. So our O-ring's going to sit right in here to seal our lens cap. And I'm going to save it. Was there anybody who was not able to create their shell? Okay, so the next feature we're going to make is, you know how on bottle caps a lot of times you have like a little kind of lip to it, kind of dovetails? We're going to do the same thing. We're going to add a cut, revolve around this bottom that's going to kind of act as a lip, and it's going to kind of dovetail into the housing, okay? So we're going to select the right plane for a new sketch, and I am on page 5-24. And I'm going to start by placing a center line from the origin. I'm just drawing like a horizontal line, just like that. And then I'm going to select this top edge. See this top edge? And I'm going to go convert entities. Question, Harvey? No, I selected this top edge and then I went convert entities to copy it into the sketch.
Again, again what that does?
Convert entities basically copies an edge or a face, or whatever you select, into the active sketch.
Okay.
Okay? And so now you see I've got this dark line and it shows a projected edge here. And I'm going to select this endpoint. I'm just going to drag it up. See that? To shorten it. And then I'm going to add a dimension. And notice that my dimension is going to be an aligned dimension. So I want to make sure that that's an aligned dimension and not a horizontal dimension. So if I click here, notice I can say smart dimension, horizontal, vertical dimension. All right, I want to make sure that this is not just a horizontal dimension, that it's actually an aligned dimension.
Draw another line there.
No. There's my aligned dimension, and I want it to be 0.25.
How do you get to a line dimension?
Yeah, there are a couple different ways. If I right click on it and notice, I should be able to like select a line, but it's also just kind of clicking on it and getting it positioned. If you zoom in, it's a little bit easier to get it aligned.
Yeah.
But you want to make sure that you use aligned and not and not a horizontal or a vertical.
It's not letting me change the dimension.
Then you might so you already have one. Click on this image. Right click. Select this line. Drag it. Pull down the top. Drag it. Now select the image. You have to drag it out to the left and rather than click here, and then we'll see how you kind of, like so select the endpoint, right, get out of the dimension. Right, select the endpoint, drag. Yeah, now you can change the size. So now you can select the dimension, click on it, now make sure, move it out close to the line. Yeah, there you So now what we're going to do is we're going to do a revolved cut. So we're going to come over to features. We're going to select the revolved cut. Because this isn't just a single line, it's an open line, what kind of feature is this going to be? Thank you. A thin feature. See, I have a TA who knows something. Yeah, so I'm going to click on my revolved cut. It says, well, how many people, if you did not exit the cut, you get this dialog. If you click yes, it's going to automatically close your line and it's going to mess up your feature. So you want to say no if you get that dialog. Okay? You want to select revolved cut. If you see this dialog that says the sketch is currently open, you want to press no, because otherwise it will automatically add lines to create a closed polygon.
We want it blind 360 degrees. We want the thickness to be 0.05. And we want to reverse the direction so it's going into the part, not out of the part. Okay? So you want to click on this to make sure that it's going into the part. Okay? I'm going to switch to... See how it's going into the part. Okay, so you want to see it go cutting into the part, not coming out of the part, and then you're going to green check. I'm going to call this lip. And I'm going to save it. Okay, was everybody able to create the lip? Does anybody need help? Now we're going on page 5-26. We're going to create a thread. All right. Now if you look at like a bottle cap, you'll notice that the thread does not start right at the bottom of the bottle cap. It always comes in a little bit. That's so there's kind of a lead, so it's going to create a better seal. So we want to put a plane into the part a little bit to the start point for our thread. Does that make sense? Okay, even if you look at a screw, the thread for the screw isn't right at the bottom. It's usually in a little bit. All right. Otherwise the thread gets stripped. Okay. So what we're going to do is we're going to add a thread plane. We're going to select this lip right here, and we're going to offset a plane into the part just a little bit. So we're going to select the plane tool on the ribbon.
Which lip did you select?
I haven't selected anything yet. I just selected the plane tool. And we're going to be selecting, see this face right here, this small face where the lip is on the end? Okay, so we're going to select, see how I selected that face? Okay? And we want it to offset into the part. We want it to go in 0.45. And notice mine is outside the part. I want it to go into this part. So I click on this flip, and that brings it into the part. Notice how the plane is before that revolved cut. Do you see that? And then we're going to green check. And that's going to be the thread plane. Okay, I'm going to save it. Anybody who is not able to create the thread plane, raise your hand. Miles is having some problems.
First time tonight, Bill.
First time tonight, that's okay. All right, so we're going to be creating a sweep. How many sketches does a sweep have? 2. What are they called? Profile and path. Alex, ding, ding, ding. Alex got it. Tom got it. Okay, profile and path. So we're going to create our path first. Our path is going to be a helical curve. I'm on page 5-27. Okay? I'm going to select the thread plane for a new sketch. So I'm going to select that offset plane, and I'm going to say new sketch. And then I'm going to select this inside circle, this inside edge, and use convert entities to copy that edge, that inside edge, to my thread plane. So I'm going to say convert entities, and then I'm going to select this inside edge and green check. And notice I get that circle copied right here onto the plane. Do you see that?
Was everybody able to copy their circle onto the thread plane using convert entities? Question?
You show we click on what you converted.
I started a new sketch on the thread plane, and then I selected this inside edge that's on the lip. So this circle right here. Got it? All right. So we've got that circle. That circle basically tells us what the diameter is going to be for our helical curve. Now to place our helical curve, we're going to go insert, curve, helix spiral. Everybody able to find it? So you're going to go insert, curve, helix spiral. And we've got a bunch of choices here. If you look at the drop down, we've got pitch and revolution, height and revolution, height and pitch, and spiral. Pitch and revolution. Pitch is the distance between the turns. Revolution is the number of turns. If we have height and revolution, that's the distance between the first turn and the second curve turn. And then the revolution's the number of turns. So it kind of does math. It says, oh, okay, if you have this many turns over this distance, that's going to be your pitch. And then height and pitch. And height's going to be your overall height, and pitch is going to be the distance between your turns. And again, it does math to calculate how many turns it's going to be. We're going to select pitch and revolution. We're going to say the pitch is going to be 0.25. So we're going to have a quarter thread. We're going to reverse direction, and we're going to say we're going to have 2.5 turns, and we're going to set our start angle to 0 degrees. Okay, and a lot of people say, what does that mean, the start angle? Okay, if you look at, we selected this as our thread plane, right? So if we have this imaginary plane across it, notice that the start and end point of our curve is going to be at 0 to the perpendicular plane. Do you understand what I just said? Okay, so if I let me turn on the visibility of the top plane. See that top plane? See how at 0 that end point is coincident to that top plane? So that's what that angle has to do, is just where this location of this end point's going to be. That's what the start angle is. Okay? And then we need to taper it, because we've got it tapered outside. So we're going to taper it 5 degrees, and we're going to uncheck taper outward. And I'm going to switch to a view so you can kind of see how it's tapering with the LensCap. Okay? So you should see it tapered. And then you're going to green check. And that's going to be our thread path. So I'm going to rename that thread path. And I'm going to save it. Alright. Now in the book, she gives the most convoluted way of creating the profile for the thread. It's really, 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 really hard to understand. Okay, so I'm going to draw the sketch on the board, and then I'm going to do it on the screen. But basically, you're going to be drawing a trapezoid on its side. All right, y'all know what a trapezoid looks like, right? Okay, so there's a trapezoid on its side. It's got a center line with the endpoints coincident to the midpoint on both sides. Okay? This side is equal to this distance. So this is going to be 0.06, and the distance from here to here is going to be 0.06. Okay? And this is going to be 0.03. Right? And then these two sides are equal. Okay? Everybody with me so far?
Yes.
Okay.
Draw that?
Sorry?
Should we draw that?
Yeah, that's what we're going to draw. Okay? So in the book, she makes it really, really complicated. This is basically what she's trying to get at. Okay? So, that is going to go on the top view, top plane. Okay? And then I'm just going to draw, and I'm going to draw it out here. And notice, I'm not going to worry about the size too much because once I add my dimensions, it's going to change, right? And then I'm going to add a center line like that. I want that to be horizontal. I want these two to be equal, right? This is going to be 0.06. This is going to be 0.03. Yeah. Yeah. Okay. Okay. Okay, and I'm trying to get it so that there we go. You broke it. So this is what it should look like when you're done. Okay. Everybody good? Not yet? Okay, now the thing is we want that profile to be on our path. And we want this endpoint here to be coincident with this endpoint here. So we're going to use the pierce. Remember we used that pierce before? So we're going to add a relationship, and I'm going to select this endpoint here, and I'm going to select this curve, and I'm going to say pierce. I'm the one on the fat end. Okay? The one on the 0.06 side. And I'm going to say pierce. Okay, and notice how it falls on. See that? So it's going facing toward the center of the part. And then I'm going to green check. I'm going to exit my sketch. I'm going to call this thread profile. And that curve is my thread path. Okay.
Okay, so this is what it looks like. Who's lost, needing help?
Okay, so we need to accept this work. So clear yourself of the and then now you need to add a dimension. Okay, so we need to, let's make that one first. Click on dimension. Click on dimension. Click on here. Click on here. Click on 3. And then double click on that 3 options for dimension. Make that 0.6. Okay. And then select this line, or actually if you select the center line, you can come down. I'll come down, click, make it 0.6. Alright, okay. And now you're gonna click on calculation. And select this center line right here. Zoom out. Okay. Select the curve. Select the curve. Yeah, select it. Okay. Save yours. You should see it. See how it's facing inside. Anybody in this ready to come? So you have to go add select it, and then zoom out. Zoom out. Don't use the one. Zoom out. Pop right on. It's the wrong side. So next time, select the midpoint. Select this side. Anybody on this side of the wall? No, right click, third selection. Right click, there's right click, there's selections. Select the midpoint. Each side of the select this curve. Display relation. Add relation. Okay. And then select. And say pierce. Do that.
So just needs to contact us.
Yeah. Everybody hear me, Pop? Everybody hear me, Pop? Everybody's got it. That's awesome. Okay, so we've got a path, we've got a profile. We're exiting out of the sketch. Okay? And now we're going to do a sweep. Select sweep. Okay? It asks us for the profile. This is where it's helpful that you've named it thread profile, and then ask for the path. Select the path and green check. And there is your thread. See that? And I'm going to call this thread.
Correct. Because it's got a draft. See that? And I'm going to save it. Okay. Questions? Lena, are you okay?
I'm just looking at this one, is that gonna be enough depth because we want by the OD and it's larger?
Yeah. Well, we made, in the book she made it bigger, but I just, yeah. Okay. So here's a couple things. I wanna show you a few things that are not in the book. I wanna create an assembly with my LensCap. Oops. So here's my LensCap. I put it into an assembly. And what I want to do is I'm going to bring in my O-ring. Here's my O-ring. Okay, so how do I get that O-ring into my LensCap? All right, so what I'm going to do is I'm going to do a mate. I'm going to mate between the top plane of my LensCap and the top plane of my O-ring, okay? And the right plane of my O-ring and the right plane of my LensCap. See how that centers it in there? Okay, but now the question is, how do I get it so that it's tangent to the bottom? What I can do is I can say from the front plane of the O-ring and this face right here, and then say I want a distance, and that distance is going to be equal to the diameter or the radius of the O-ring. So I'm going to just put in for just 0.125 for now. Okay. Now I want you to notice I'm going to do a section of my assembly so you can see where my O-ring is. See that? My O-ring's not sitting right. Remember, this O-ring has configuration, it has different sizes. So I need to figure out what size to use. Right now it's using small. If I come over and I say, okay, let's see what it looks like with the medium. Okay, well the medium's too big. So I need to add a size that's just for the LensCap. Okay, so how do I determine that size? Okay, I'm going to come over to evaluate, and I'm going to do a measure from this point to this point, and the distance is 105.6 millimeters. And then I'm going to do a distance just of that edge, and that edge is 6 millimeters. So it's like 108 millimeters is going to be the diameter that I want. So I'm going to come over to the O-ring. I'm going to open it up, and I'm going to open up the table, edit the table. And I'm going to add another size, and I'm going to call this size LensCap. trying to find my sizes. Okay. So I'm going to add a size called LensCap. The diameter of the path is going to be 108 millimeters. And I'm going to make the diameter 6 millimeters. So I have now added a new configuration called LensCap. So now if I go to my assembly, I can configure the O-ring to LensCap. See how it fits in there? Now I see that maybe I want to adjust that diameter a little bit more. And I'll say I want it to be 108.5. And save it. And now it's looking a little bit better. You can see how I can modify my table so I can get my LensCap to fit in there and getting it to look pretty good. See that? Alright, so that's one thing I want you to keep in mind when you're assembling. The other assembly I want you to look at is this LensCap is going to be in an assembly with the lens. And the lens is going to be in an assembly with the bulb. So I'm going to add the bulb to this assembly, and I want to show you the best way to assemble the lens with the bulb. What I want to do is I start by adding a concentric mate between this face and this face. And I want this bulb to sit in that counterbore hole that we created. So what I'm going to do is, I'm going to create a section. And notice now I can kind of see the faces a little bit better. So now I can do a coincident between this face and that face to seat that bulb in there just right. See that? Okay? That's really hard to do if you're not in a section view. Okay?
Where's the selection for a section?
You select your plane and then select right here for section.
Oh,
Okay?
okay.
And then to unsection it, you just toggle it. So you just click it. Okay? So those are two things you need to be aware of as you start creating your documentation. And on Thursday, we're going to start working on our final part for our flashlight assembly, which is the housing. Okay? And we're in lab.
How do you turn the light bulb on?